Hi everyone, today I've got a functions problem solving set of questions. This is for the IB. Professor Vinculum investigated the migration season of the bulbul bird from their natural wetlands to a warmer climate. He found that during the migration season, their population P could be modeled by this function here, where t is greater than or equal to 0, and t is the number of days since the start of the migration season. Part A, number 1. Find the population of the bulbul birds at the start of the migration season. At the start of the season, t is going to be equal to 0. So for part A, I'm going to have p equals 1350 plus 400 outside of 1.25 to the power of negative 0. Here you could just type this into your calculator, or you know that anything to the power of 0 or negative 0 is going to be 1. So that second term there is going to be equal to 1. So it's just going to be 400 plus 1,350. Just to show you, I'll do it in my calculator as well. And we get 1,750. So this is going to equal 1,750. That is for part AI. Second part, AI. Find the population of the bulbul birds after 5 days. Now, before you start, you notice it is worth 2 marks. So you need to show 2 marks worth of a response. So this one, you need to show this. You need to show you're working out for this. So 1350 plus 400 times 1.25 to the power of negative 5. Again, type all that into your calculator. And we get an answer of 1481.072. Find the population of the bulbul birds. Well, you can't have 0.072 of a bulbul bird, right? So your answer can be equals 1481.072 and then approximately 1481. Find the population of birds after 5 days. For part B, calculate the time taken for the population to decrease below 1400. Well, the population was P, so we're going to put 1400 equals 1350 plus 400 outside of 1.25 to the power of negative t. If we can work out the time that it's exactly equal to, then we can, anything after that, the population is going to decrease more. So let's go to my equation and let's go solver. Type this equation in. Solve it, and we get an answer of x, or really t equals 9.3, let's do 9.32. That would be to 3 significant figures. This question is worth 2 marks, so you need to show the top line, you need to show your answer of t equals 9.32. Now the mark scheme that I'm looking at says that 9.32 days is an acceptable answer. So that's fine for this question. If you wanted to, you could also say GDC use equation solver, just as further justification. Last part, so for part C, it says, according to this model, find the smallest possible population of bulbul birds during the migration season. So multiple ways of doing this. It's only worth 1 mark, by the way, so you only get an answer, or you only get a mark for the correct answer. So we have got this function. Let me write it out again. 400 outside of this. This is an exponential function because our x variable, or the t, is raised to the power. So one of your rules about exponential functions is that the horizontal asymptote equals whatever the c value is, and the c value is the constant. So in this case, the asymptote occurs at 1350. So going back to the question, according to this model, find the smallest possible population of bulbul birds. The smallest population is 1,350. If you weren't sure about that, and if you had completely forgotten that that rule existed, then you could just go to your calculator and use the graph function, and you could graph that function. So you can see that I've just typed it in, and now if I draw it, first thing you're going to need to change is the view window. So you just press that view window at the top. The y values first. I'm going from 0 to 1800. Why am I doing 1800? Because if you remember back in the first question, we had a maximum value of 1750. So I've just chosen 1800 just to, give me something good to look at, basically. And my x values are going from 0 to 180. Now, why am I choosing 180? In the question, it doesn't really give you much context as to what the domain needs to be. It just says that the domain has to be greater than 0, greater than or equal to 0. But in the context of the question, you've got some birds and they're migrating. So the maximum, the very maximum is going to be 365 days, and a migrating season is going to be less than that. It's either going to be 6 months, or in all likelihood, it's only going to be a few months. So I've just chosen 180 just to give me, again, something good to look at here. Next part is you can see where the graph is bottoming out. So it comes to a natural asymptote there. Now I can use my trace function, and if I just scroll right to the start, and now I'm focusing in on the y values. Trace it again. You can see that my y values, just when I get back to the start again, my y values, okay, here we go, 1,381. And now as I go right, they're getting less and less and less. Now it's 1,352. And if I keep going, keep going, keep going, you can see that they naturally bottom out when y equals 1,350. So that, if you had forgotten that rule about the asymptote being the c value, then you could just use your graph and you could see that the minimum, the smallest population is going to be 1,350. So back to my question, for part C, 1,350. For all the other questions, remember 3 significant figures unless it says otherwise, or in the case of part A, II, the population has to be a discrete variable because you can't have 0.072 of a bird.